Welcome to Creata classes. This lecture is under the median lecture series. We are covering the medians. In this lecture, we will cover the relation between medians and sides of the triangle. The relations that we are going to study are very important relationships, as direct questions are generally asked in many competitive exams. So you should know the relations. Let's start with the first relation. For that, let's take a triangle ABC with median as AD. We have joined the vertex with the midpoint of the opposite side. I am just repeating the fundamentals. Further, D is the midpoint, so we can say BD is equal to DC. Let's extend the line AD to point M such that AD is equal to DM. We have assumed AD is equal to DM. This will be used. Let's join BM and CM. If we take the triangle ABD and CDM, BD is equal to DC, that is D is the midpoint. AD is equal to DM, that is by the construction. And angle ADB is equal to angle MDC. Both are vertically opposite angles. So by SAS rule, we can say both the triangles are congruent to each other. Those who have not done the congruency, I am just repeating the fundamental of congruency. SAS rules state that for any two triangles whose side are matching are the congruent triangles. Congruent triangle means triangles which are exactly matching each other, that is exactly overlapping each other. So in this case, these sides and these angles are equal. So by SAS rule, we can say both the triangles are congruent to each other. And by CPCT, we know the corresponding sides of the congruent triangle are equal to each other. So can we say AB is equal to MC? Okay, both of these sides will be equal to each other. Further, if we take the triangle AMC, we have taken the triangle AMC. Here, can we say AC plus CM is greater than AM? Why? Because we know the property of the triangle, that is sum of the length of any two sides of a triangle is greater than the length of the third side. So we can say sum of these two sides, that is AC plus CM, is greater than the third side, that is AM. And just now we have proved these two sides are equal, that is CM is equal to AB. So we can say AC plus AD is greater than AM. And we know AD is equal to DM. Can we say AB is equal to twice of AD? So we got AC plus AD is greater than twice of AD. This is the first relation under this lecture. This is very important. Direct questions are generally asked from this relation only. That is AB plus AC, that is sum of two sides is greater than twice the length of the median which is coming between these two sides. So AB plus AC is greater than twice of AD. This is the first relation. Moving further, if we take BF and CE also as the medians, and if we apply the same relation, can we say AB plus BC is greater than twice of BF? And AC plus BC is greater than twice of CE. We have got three relations. Let's add all the three relations. We got twice of AB plus BC plus AC is greater than twice of AD plus BF plus CE. 2 and 2 will cancel out. We got AB plus BC plus AC is greater than AD plus BF plus CE. Here AB, BC and AC are the sides of the triangle, and AD, BF and CE are the medians of this triangle. So can we say sum of sides of the triangle is greater than sum of medians of the triangle? This is also the important relation. If we take any triangle, if we add all the three sides and if we add all the three medians, the sum of the sides of the triangle will always be greater than sum of the three medians. This is our second relation. So we got two relations. Let's move further. Let's take a triangle ABC with medians as AD, BE and CF. Let's check the triangle AGC. Okay, this is a triangle. And we know the property of the triangle, that is sum of the length of any two sides of a triangle is greater than the length of the third side. So can we say AG plus CG is greater than AC? Similarly, if we take the triangle ABG, Here also we can say AG plus BG, that is sum of two sides, is greater than the third side, that is AB. Similarly, for the triangle BGC, we can say BG plus CG is greater than BC. If we add all these three equations, we got twice of AG plus BG plus CG is greater than AB plus BC plus AC. And we know the centroid divide the median into ratio of 2:1. So we can say AG is 2/3 AD and GD is 1/3 AD. Let's replace AG with 2/3 AD. Any issue? Similarly, we can replace BG with 2/3 BE and CG with 2/3 CF. On solving, we got 4 times AD plus BE plus CF is greater than 3 times AB plus BC plus AC. And AD, BE and CF are the medians of the triangle, and AB, BC and AC are the sides of the triangle. So we got a relationship that is 4 times sum of medians of a triangle is greater than 3 times the sum of sides of a triangle. Again, an important relation. Moving further, again with the same triangle ABC with medians as AD, BE and CF. Here we will take different triangles. Previously we have taken these triangles. Now we will take these three triangles. If we take the triangle ACF, can we say AC plus AF is greater than CF? Again, we have applied the property of the triangle. That is, the sum of the length of any two sides of a triangle is greater than the length of the third side. And we know F is the midpoint of AB. So we can replace AF with half of AB. Okay, both of these line segments are equal. So we can say AF is half of AB. So we got AC plus half of AB is greater than CF. Similarly, if we take the triangle ABD, we can say AB plus half of BC is greater than AD. Same philosophy we have used. And similarly, in the triangle BEC, we can say BC plus half of AC is greater than BE. If we add all these three equations, we got 3/2 times AB plus BC plus AC is greater than CF plus AD plus BE. Which means that 3 times the sum of sides of a triangle is greater than 2 times the sum of the medians of the triangle. Here AB, BC and AC are the sides of triangle and CF, AD and BE are the medians of the triangle. This is again the important relation. So we got 4 relations between sides of the triangle and the medians of the triangle. These relations basically compare sides and medians of the triangle. That is, which portion of the equation is greater or lesser. Now in the next relation, we will see the formula that will actually link the sides of the triangle with the medians of the triangle. It is known as Apolloinus theorem. This theorem or the formula will be used to actually calculate the missing length of the median or the sides of the triangle. Let's see what it is. This is the formula of Apolloinus theorem. This theorem shows the relationship between sides of the triangle and the length of the medians. As per this theorem, the sum of the square of any two sides of any triangle equals twice the square on half the third side together with twice the square on the median bisecting the third side. This is the relation. If we take a triangle with sides as A, B and C and AD as a median, the relation will be A square plus B square is equal to twice of AD square plus C/2 square. Here AD is the median. We have taken two sides A and B and the median that we have taken, that is AD, is between these two sides only. If we take side A and side C, then we have to take the median BE. Okay, then this relation will change. That will be A square plus C square is equal to twice of BE square plus B/2 square. If we take the third median as CF, then the relation will be B square plus C square is equal to twice of CF square plus A/2 square. These relations are known as Apolloinus theorem. Let's check the proof of this theorem. Okay, this is very important. This will help you in solving many questions related to length of the median and side of the triangle. Let's take a triangle ABC with median as AD. Okay, AD is the median. So D will be the midpoint, that is BD will be equal to DC. Let's take the sides of this triangle as A, B and C, and let's denote the median as X. Let's take BD as M and DC as N. Here BD and DC are equal, so M is equal to N. Just for differentiating, we have taken two variables, that is M and N. Further, let's draw a perpendicular from the vertex A to the side BC. Let's denote this perpendicular as H. This will be the height of the triangle. Let's take ED as Y. Then BE will be M minus Y. BD is M. This complete length is M. So this will be M minus Y. Further, if we take the triangle ABE and apply the Pythagoras theorem, then we will get A square is equal to H square plus M minus Y whole square. Okay, simple Pythagoras we have applied. Further, if we take the triangle AEC, we got B square is equal to H square plus N plus Y whole square. We have got two equations. Let's add both the equations. We got A square plus B square is equal to 2H square plus M minus Y square plus M plus Y whole square. And we know BD is equal to DC, that is D is the midpoint, that is M is equal to N. So we can replace N with M. Okay, nothing will change. So we got A square plus B square is equal to 2H square plus M minus Y whole square plus M plus Y whole square. Further, let's expand this M minus Y whole square and M plus Y whole square. On solving, we got 2H square plus 2M square plus 2Y square. Let's take 2 common from Y square and H square. Are you able to observe Y square plus H square will be equal to X square? Why? If we take the triangle AED and apply the Pythagoras, we got Y square plus H square is equal to X square. So we can replace Y square plus H square with X square. So we got A square plus B square is equal to twice of M square plus X square. So we got this relation, that is A square plus B square is equal to twice of M square plus X square. Let's go back to the figure. Here A and B are these two sides and X is the median, that is AD, and M is C by 2, that is half of the side BC. So we can replace this with A square plus B square is equal to twice of C by 2 square. We have replaced M with C by 2 plus X square, or we can replace X with AD, that is AD square. Just for simplification, you can take whatever you like. This equation or this relation is known as Apolloinus theorem. As per this theorem, the sum of the square of any two sides of any triangle equals twice the square of half the third side, that is C by 2 square, together with twice the square on the median bisecting the third side. Here AD is the median, so AD square. So this is very important relation, will be used where we have to relate the sides of the triangle with the length of the median. So let's move further. Our next relation will be based on the Apolloinus theorem only. Let's find the value of AD square from this relation. We got AD square is equal to 2A square plus 2B square minus C square upon 4. Similarly, we can say BE square, that is this median, will be equal to 2A square plus 2C square minus B square upon 4. Okay, same formula we have used. Similarly, we can say CF square is equal to 2C square plus 2B square minus A square upon 4. If we add all these three equations and solve, we got a relation, that is 4 times AD square plus BD square plus CF square is equal to 3 times A square plus B square plus C square. And AD, BE and CF are the medians and A, B, C are the sides of the triangle. We can also say this equation as 4 times the sum of square of a median is equal to 3 times sum of square of the sides. This is our another relation. So we have done with all the relations between sides of the triangle and the medians of the triangle. So these are the relations that we have covered in this lecture. Total 6 relations we have covered. The first relation that we have covered is AC plus AB is greater than twice of AD. Here AC and AB are the two sides of the triangle and AD is the median. And this median AD is between these two sides, that is AC and AB. In other words, we can say the sum of two sides of the triangle is greater than twice the median, which is between these two sides. And based on this relation, we have derived our second relation. That is, the sum of sides of the triangle is always greater than sum of the medians of the triangle. Then we have seen these two relations, that are 4 times sum of the medians of the triangle is greater than 3 times sum of the sides of the triangle, and 3 times the sum of sides of the triangle is greater than 2 times the sum of medians of the triangle. If you observe these two relations, there are chances that you may interchange the numeric 4 with the 3 or 3 with the 2. There are much chances that we interchange these numbers. So the remembering technique is that the numeric 3 will always come with the sides of the triangle. Triangle, that is triangle, 3 sides or 3 angles. The number 3 will always comes with the sides of the triangle. Okay, in this relation, 4 times the sum of median is greater than 3 times the sum of sides of the triangle. So the numeric 3 is coming with the sides of the triangle, and in this relation the number 3 is again coming with the sides of the triangle, where the 3 times the sum of sides of the triangle is greater than 2 times the sum of medians of the triangle. Got it? So a small remembering technique. After that, we have seen the Apolloinus theorem, which is very important, that defines the relation between the sides of the triangle and the median. And based on the Apolloinus theorem, we have derived the last relation, that is 4 times the sum of square of median is equal to 3 times the sum of square of sides of the triangle. So these are the relations between the sides of the triangle and the medians of the triangle. That's it for this lecture. Thank you very much for being with Creata classes. Bye for now.